All right, our second to last segment of the entire textbook, section 11.4, using valence bond theory. Okay, so using valence bond theory, it can be used to explain certain observations, one of which is that compounds with multiple bonds are more reactive. That's a key. So that's a combination of observations as well as a theory that someone devised. So multiple bonds, more reactive. According to valence bond theory, the strength of a bond is related to the degree of overlap. Okay, so a double bond, for instance, has a higher degree of overlap than a single bond. The side-to-side overlap between p orbitals in a pi bond is much less than in the head-to-head overlap in sigma bonds. Thus, pi bonds are easier to break. Pi bonds are easier to break than sigma bonds, making them molecules with double and triple bonds more reactive. Okay, so valence bond theory can be used to explain the observation that compounds with single bonds have free rotation around those bonds, but compounds with multiple bonds do not. Now, rotation of atoms around sigma bonds does not interfere with the head-to-head overlap that forms the bond. However, the side-to-side overlap that forms the pi bond requires that p orbitals on two atoms be in the same plane. Rotation of atoms around a pi bond would break that pi bond. So when we have a double or a triple bond, so a single pi or two pi bond, then there's no rotation. Whereas when there's only a sigma bond, then you have complete rotation. We can see that in the case of butane. So butane is C4H10, then you've got C, 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 and then all the white ones are hydrogens. And what we've got is this molecule, if you look at where I put my X, that does not move. However, where I put my Y, that now has moved up into a higher position. Okay, so that would be an example of rotation about this bond right here. Now, if we compare that to 2-butene, well, 2-butene is going to have a total of 4 carbons, but what we're also going to have is we're going to have CH3, CH, CH, CH3. We've got this double bond right here, and that kind of locks it in position. And it's stuck there. We've got this double bond that basically makes the molecule much more rigid. Now, what this all is asking you to do is say, use valence bond theory to determine and explain whether propane, C2, or CH3CH2CH3, or propene, CH3CHCH, is more reactive. And we've got this double bond here. Okay, so one of the principles that we talked about previously was more bonds. So whenever I say that, I mean a 2x bond, 2x or a 3x bond in a position, that's going to make it more reactive. The reason for that is pi bonds are weaker, therefore easier to break. So we can arrive at the conclusion that this propene is more reactive than propane. All right, well, that's some important takeaways for how to use valence bond theory. I hope this was helpful, and I'll see you in the next and last section.